What is the technology changing modern warfare today? Drones. Some can identify targets. Some can track moving vehicles. Some can even make decisions without a human pilot controlling every movement. Most people think this technology is a product of the 21st century. But what if I told you that more than 80 years ago, the United States was trying to solve exactly the same problem? There was no artificial intelligence, no GPS, no computers, no digital cameras. So, how do you build a weapon that can guide itself? America's answer was unbelievable. If there were no drones, there were pigeons. And believe it or not, the US government actually funded the idea. To understand this story, we have to go back to World War II. After the attack on Pearl Harbor, the United States was fully engaged in the Pacific War. American bombers could carry enormous amounts of explosives. But destroying a moving warship was another challenge entirely. A battleship never stayed still. Wind changed. Altitude changed. The target kept moving. The moment a pilot released a bomb, control was gone. From that point on, physics decided everything. The military didn't need a bigger bomb. It needed a smarter one. Today, we solve that problem with satellites, sensors, and artificial intelligence. But in 1943, none of those technologies existed. The question became simple. How do you make a weapon keep thinking after it leaves the aircraft? No one had the answer. Until an unexpected scientist proposed one of the strangest ideas in military history. His name was B.F. Skinner. He wasn't an engineer. He wasn't a weapons designer. He was a psychologist. For years, Skinner had studied animal behavior, especially pigeons. Most people saw ordinary birds. Skinner saw something different. He saw a brain capable of learning patterns and responding with incredible consistency. His pigeons could recognize shapes. They could distinguish images. They could repeat trained behaviors over and over again. Then, one day, a simple question changed everything. If a pigeon could keep focusing on a picture, could it also keep focusing on an enemy ship? And if it could it guide a bomb? The idea sounded ridiculous, yet the military didn't laugh. Instead, they approved funding. Project Pigeon had officially begun. This is where the story becomes unbelievable. Inside the nose of the weapon was a small compartment. Inside that compartment sat one or sometimes three trained pigeons. At the front of the bomb, a lens projected the target's image onto a screen. The birds watched that image. Whenever the target drifted away from the center, they pecked toward it. Those pecks activated mechanical controls connected to the bomb's guidance system. The control surfaces adjusted. The weapon corrected its course. Then, the pigeons continued pecking, again and again and again. Now compare that to a modern autonomous drone. A drone uses cameras, computer vision, artificial intelligence, flight computers. Project Pigeon used an optical lens, a pigeon's eyes, a pigeon's brain, a mechanical control system. Different technology, the same objective. Find the target, track the target, correct the course. Many military officers expected complete failure. After all, this was supposed to be a serious weapon, not an experiment involving birds. But the tests surprised people. The pigeons stayed focused. They continuously followed the target image. Their reactions created steady guidance corrections. The project was far from perfect, but it proved something important. A weapon could continue adjusting its path after launch. For a brief moment, Project Pigeon looked like a genuine solution. So, if it worked, why did it disappear? The answer wasn't failure, it was progress. While Skinner trained pigeons, other scientists were improving electronics. Radar systems advanced. Guidance technology improved. Computers, though primitive, were becoming more practical. Military leaders faced a choice. Should the future rely on trained birds or electronic systems? The decision was inevitable. Project Pigeon gradually lost support. Skinner later refined the concept into another program called Project Orcon. But by then, technology had moved in a different direction. Silicon was replacing biology. Circuits were replacing instinct. The age of electronics had arrived. Today, autonomous drones use artificial intelligence to recognize and track targets. They analyze images. They make corrections. They continue flying without constant human input. Project Pigeon was not the direct ancestor of these systems. History is more complicated than that, but it attempted to solve the same fundamental problem: create a weapon that could find, follow, and strike a target on its own. The tools were different. The vision was remarkably similar. When electronics couldn't solve the problem, scientists turned to biology. In many ways, Project Pigeon was less about pigeons and more about autonomy. It asked the question that engineers are still asking today: can a machine make decisions without us? History remembers successful inventions. It rarely remembers ideas that arrived too early. Project Pigeon never changed the outcome of World War II. It never became the future of warfare, but it revealed something extraordinary. The dream of autonomous weapons did not begin with artificial intelligence. It began decades earlier, in a small laboratory, with a psychologist and a pigeon. Sometimes history's strangest ideas are not the dumbest ones. They're simply waiting for technology to catch up. And perhaps that's the real legacy of Project Pigeon. Before AI, before autonomous drones, before smart weapons, there was a bird that inspired one of the boldest ideas of the 20th century.